is something very simple, the shape of craters.
Shape of craters.
Yeah, you ever look at a picture of the moon, any photograph of the moon, what shape are the craters?
Well, they're all concave little circles.
Yeah, they're perfect circles.
Yeah.
Every single one of them. The big ones, the little ones, the medium ones, they are perfect circles. It turned out it was a mystery why all craters are perfect circles. For the longest time. It was a mystery until about 100 years ago.
Okay.
And let me tell you why it was a mystery. All right? So your first thought is, well, the moon doesn't have an atmosphere. Maybe it's getting slammed by meteors.
Right.
Okay? But is every meteor coming straight down at a 90-degree angle so that when it hits, it makes a surely some of them are at an angle. Right. You'd expect some craters to be elongated.
Right.
And you'd have all sort of shapes from circle to very flattened circles. You'd expect that.
Some of them would be divots, when you swing a golf. It'd just be like a.
Oh, okay.
I mean, where it came in on the angle.
On the angle because you'd have the slope would be different on one side than the other.
Than on the other.
Because it slid in.
It slid in.
So you'd expect that, and it is nowhere to be found on the moon. So this energized the geologists because we know that the dark areas of the moon is where lava has once flowed. Okay?
Oh, cool.
I think they call it basalt. It's dark and it's lava fields, all right? And by the way, the Apollo astronauts aimed for those places because they're flat. If you're going to go 250,000 miles and land sideways and fall over, that's it, all right? So they found the flattest areas. And those are called seas. These are, before people knew that the moon didn't have weather like we have, or oceans, these large flat areas were called seas, the Sea of Tranquility. Okay, that's where it gets its name.
Nice.
And all the seas were named after psychological states or physiological states. So there's a sea of fecundity. There's a sea.
Oh, all right.
Right? Yeah, right. So there's they're flat because lava in liquid state flattens out, right? There you go.
Okay.
All right. So wherever there was a crater, it was round. So the geologists said, it's probably not these asteroids because they'd have to all come in perpendicular. They're probably all volcanic craters. Because volcanic craters, you punch up, it makes a hole, the hole is a circle.
Right.
Okay? You can pull that off. So that's how it stood for the longest while. Until people saw craters on top of places where it didn't look like lava had flowed.
Right.
Okay, so how are you going to have a crater and no lava signature anywhere near it? What's up with that? And so this was a conundrum, okay? I have a book from 1890, and it says, believed by many to be volcanic in origin, perhaps they're actually of asteroid impacts, we are not sure. Okay. By the way, it was that way for most of the 20th century. Until computers came along and you could simulate impacts.
Nice.
You want to simulate it. Okay, so here you go. You ready? If you have an impactor that comes in straight into a surface, it makes a circular crater. Right. If you send it at an angle, it will make an elongated crater. Okay? This will happen. So they're saying, no, wait a minute, let's send it in faster. Turns out there is a magic speed with which you can send in an asteroid, and on collision, it will make a perfect circle no matter the angle it hits.